Hello, how are you doing? Today we are looking at the introduction to linear systems of equations. All right, the goal here is to give you a little bit of terminology of the things you need to know when you're dealing with linear systems. First of all, what is a system of equations? A system of equations is a set of two or more equations. Real difficult there. A linear system, therefore, is a system of equations using only linear equations, meaning lines. And when we deal with these, typically we're going to be using two equations. And finally, the solution of a system is the set of values for the variables, normally x and y, that work for all of the equations in the system. And the answers have to work for all of the lines to be correct. Now, in dealing with two lines in a system, typically we have three options. Most typical option is you have two lines that are crossing. Notice the green and the pink lines are crossing. They share one point. The terminology for this is it is a consistent and independent system. They share exactly one point. Second type is a set of parallel lines. Since they do not share any common points, they do not cross, it is called an inconsistent system. And once again, as I said, there are no common points. Third possibility, and this is the weird one, anybody think of it? This is unusual. This is where you have two equations for the same line. Notice the pink line is lying right on top of the green line. This is a consistent system because they share all of the points on the lines, and it is dependent because there's more than one answer. So in this case, there's an infinite number of common points. So, quick review here. Consistent means that the two lines have at least one point in common. Inconsistent will mean that the lines have no points in common. Independent means there's only one point in common, whereas dependent means there's an infinite number of common points. All right, for a quick example here, we're going to go through this graphically. The first equation, the y equals negative x plus 5, our intercept will be at 5. The negative x means the slope is negative 1, so we're going to go down 1, right 1 for each point there. Now, since I'm doing this on the smartboard and I don't draw real good straight lines, I'm going to put lots of points in. If you have a straight edge, you might be able to get away with putting in fewer points. Otherwise, I would do lots of points to help keep your line straight. And as you can see, my line is not super straight, but fairly accurate. All right, the second equation, the 2x minus 4. Our intercept is at negative 4. I should say it's the y-intercept. Our slope is 2, meaning we're going up 2 for every one we are going over. Once again, I'm doing lots of points. Try and help my line out. All right, so as far as classification goes, this would be a consistent and independent case. The two lines are crossing in one point right here. If my lines were a little neater, we would be able to tell where it is exactly. The coordinates for this point should be at 3 and 2. Good way to double check to make sure this works is to stick the numbers back in and see if it makes sense. If we put 2 in for y, we'd have negative 3 plus 5. Negative 3 plus 5 would be 2, so it works in the first equation. And if we put the 2 in here, 3 in for the x there, that should be a minus, not an equals. You see we'd have 6 minus 4, that would be 2 again, so this one works. That point is on both lines, therefore it is the solution, the answer to these two equations. Next example. All right, top equation, y-intercept is at 3, slope is at negative 1. And then the other equation starts with y-intercept at -2. Also has a slope of -1. Don't know what you guys are seeing out there. Some of this is hiding on me. All right, in this case, the two lines are parallel. They do not cross. They do not share any points in common. This would be an inconsistent system. And how can you tell ahead of time that you're going to have an inconsistent system? If you take a quick look here, both equations have the same slope. But notice they have different intercepts. So same starting spot, right, different starting spot, same slope, not gonna cross. All right, last case. I'll give this one away. This is going to be the consistent and dependent case. Typically, they are going to hide the fact that they have the same equation. So, first one, written in standard form. I don't know if anybody remembers the intercept method of graphing. If we let x equals 0 to start with on the top equation, that would leave us -2y equals 10. If we divide by the -2, y would end up equaling -5. That means we have a point at 0 and -5. If we set the y equal to 0, that leaves us 5x equals 10. X would be 2 in this case. That means we'll have a point at 2 and 0. All right, if I sketch in a couple other points with a similar slope, there's the first line. And notice if we look at the second equation, the intercept's -5, which is right where we had the point there, and the slope is 5/2. So we're going up and over, giving us the same points we have for the previous line. So as I stated, this would be a consistent and dependent case. All right, now something to look forward to when we solve algebraically, and this will be coming up next. When you have a consistent and independent case, you'll have solutions for both x and y. So when you work things out, you'll get x equals, and this I should say it's an example, x will be 2, y will be 3, indicating that you'll have a point at 2, 3 where the two lines would cross. When you solve algebraically for a consistent and dependent case, you'll end up with a true statement. Either 0 equals 0, 5 equals 5, anything that is a true statement. This means all the variables and everything would cancel out when you do the elimination method or the substitution method, and hence you got the same equation for the same line. In the inconsistent case where you're going to have the parallel lines, the variables will cancel out, but the numbers will not cancel out. You'll end up with something statement-wise like 0 equals 5, which we know is not true. You could end up with 2 equaling 7. Doesn't matter. Once again, examples, not true. So if you get a not true statement when you do it algebraically, you're going to have an inconsistent system. You have parallel lines. Okay, I hope this was a good warm-up. Let you know what the stuff is. And if you got any questions, see your teacher. Bye.